Okay, good evening, everybody. This will be the IRTF Open Meeting. We'll just get started in a couple of minutes to give people time to come in. Okay, I think it's time to get started. Welcome, everybody. This is the IRTF Open Meeting. My name is Colin Perkins. I'm the IRTF Chair for another few months. Welcome. You have probably all seen very similar slides to this. This is perhaps a slightly different version because this is the IRTF Note Well, but a reminder that the IRTF follows the intellectual property disclosure rules similarly to the IETF. And that by participating in this meeting, you agree to follow those rules and processes, and you agree to disclose any intellectual property you have when talking at the microphones or making comments. In addition, a reminder that we make recordings of the sessions, that the recordings of these meetings are made and will be available online. If you are participating in person and you're not wearing one of the red do not photograph lanyards, then you consent to appear in such recordings. And if you speak at a microphone or present here, then you will be recorded. This meeting is being recorded, it's being live streamed, and the recording will go on YouTube afterwards. So if you join the session and you speak at the microphone, or if you join online, be aware that you're being recorded and the recording will be public. In addition, we have a code of conduct and a privacy policy and so on. Please be aware of the privacy policy. Please also try to work respectfully with other participants. We want this to be a pleasant experience for everybody, so please do act in a respectful way to the other participants. If you have any concerns about that, please talk to me or please talk to the Ombuds team, or if it's in any of the other research group sessions, talk to the research group chairs or to myself or to the Ombuds team, and we will endeavor to address them. And the anti-harassment procedures for the IETF also apply to the IRTF. If you're participating in person, please do sign in via MeetEcho using the on-site tool. And if you want to join the queue, please join the queue from MeetEcho. If you are joining remotely, again, join using the full client. We have a unified queue for both local and remote participants for questions. So please do use the queuing tool. And the URLs on the slide, if you're having problems, explain how to report issues with the tooling. So this is the IRTF Open Meeting. And the goal of the IRTF is to focus on some of the longer term issues related to the internet. While the IETF, the parallel organization, focuses on standards making. The IRTF is a research organization. It's not a standards development organization, and we're not here to develop standards. In particular, in this group, which is the IRTF Open Meeting, but also in the research group meetings. The IRTF can publish RFCs. It can publish informational and experimental RFCs, but the primary output of much of the IRTF and much of the research groups is in the form of academic papers rather than RFCs. IRTF is organized in the form of a number of research groups. There are currently 15 research groups, of which 14, those highlighted in blue on the slide, are meeting later this week. So if you're interested in any of these topics, from the cryptographic forum to the formal methods group, from the quantum internet to human rights, please do find the groups and go along to them later this week. We have one group which is in the process of closing. The computation in the network research group is in the process of closing down. Thank you very much to the chairs, to Marie-Jose, to Jeffrey He, and to Yves Schuler. I think Yves is in the room, the other two are possibly remote. But thank you to the chairs for all your contributions. Thank you to everyone who participated in that group. It's had a whole bunch of interesting discussions over the years. I think we've learned a lot from this group, but the research area has matured and shifted over the years. And I think the focus of interest has moved away from the charter of that group. And after discussion with the chairs, we decided that the right thing to do was to close that group. And if there is further work in that space, we can consider chartering follow-on groups with a different focus as appropriate. So that group has one document in its way through the approval process, and once that document is published, the group will then close down. Also, thank you to Melinda Shaw, who has she was a research group chair for many years and has been serving as an at-large member of the IRSG for the last few years. Melinda has retired and has decided to also step back from her position on the IRSG and does not apparently consider participating in the IRTF as a restful retirement activity, and who can blame her? So she is retiring after this meeting. Thank you very much to Melinda. She has been a tremendous asset to the IRTF and to the IETF over very, very many years, and she will be very much missed. So as I say, the IRTF can publish RFCs. As you will see, we do not publish many. Since the last meeting, we have published precisely one RFC, RFC 9620, the Guidelines for Human Rights, Protocol and Architecture Considerations. And that's taken a considerable amount of time to produce, but I think we've got a nice document in the end. So congratulations to the authors and to the Human Rights Protocol Considerations Research Group in preparing that. We have a number of ways of supporting participation in the IRTF. One of these is that we run a diversity travel grant program, and we have support from a number of companies and organizations. You see their logos on the slide there, and we're very much grateful to that. We've managed to bring a number of people to this meeting. This is possibly a little small, the label is possibly a little small to read. We've got breakdowns of gender and geographic location of those participants on the slide, and you can see those on the slide from the data tracker. But I'm very pleased that we brought a significant number of people from parts of the world where they do not usually manage to attend IETF and IRTF meetings. And we've got a pretty good gender balance in the participants as well. So thank you very much to the sponsors for the travel grants. The travel grant program for the IETF in Bangkok will open shortly after this meeting, so keep an eye out on the URL on the slide if you're interested in applying for diversity travel grants. We've also been working on an IRTF code of conduct for the last year or 18 months or so. I was hoping to announce that this had been approved. It hasn't quite been approved. It is in the IRSG ballot. We've got a couple of details to resolve here, but hopefully this will be approved either later this week or in the next couple of weeks. The IETF has had a code of conduct, RFC 7154, for a number of years. That has very much been focused on effective conduct of the standards process. The new IRTF Code of Conduct is focused on effective conduct of research. So it includes things such as research integrity, which don't really make sense for the IETF Code of Conduct. Both codes of conduct refer to the same anti-harassment policy, the same inclusive language guidelines, the same ombuds team, and so on. So all the common content for things like anti-harassment and so on is in common documents which are referenced from both. The differences are to do with the standards process rather than the research process. So thank you again to the IRSG, to everybody else who has contributed to that document. As I say, I'm hoping that we will have this approved in the next few weeks. I think the one remaining issue is exactly when and how the use of AI should be credited, and whether things like AI grammar and writing tools should be exempted from the requirements for credits. So we're down to fairly small issues here. Hopefully that will be approved soon. In addition, as I hinted at the beginning, I am stepping down as IRTF chair, and my term will end at the next meeting in March 2025. The IAB has been running a nomination process for my replacement as IRTF chair. You see the candidates listed on the slide there. The IAB has a call for feedback on those nominees. If you have any opinions as to their suitability for the IRTF chair position, and you've not already given feedback to the IAB, please do so by end of day on Wednesday this week, so the IAB can make the decision as to who gets this lovely job after me. Also, as part of the process of handling the nominations for the next IRTF chair, as you might expect, I had a number of long conversations with people who were considering nominating themselves. And that led me to think a little more about the role of the IRTF. And I put together a draft which describes how I see the role and purpose of the IRTF as a result of that. I've discussed it with the IRSG. I've had a bunch of useful feedback. If other people in the room have or online have opinions, please do read this. I would be very interested in getting community feedback on this draft, see if it matches your understandings of what the IRTF does, and see if there's anything I've missed or anything that you think I have misquoted. So please do send feedback on that document. In addition to the research groups, we also run the Applied Networking Research Workshop along with ACM SIGCOM. This is an academic workshop that co-locates with the IETF meetings in July. It's a peer-reviewed workshop with the proceedings published in the ACM Digital Library. Very pleased to announce that Anna Brunstrom from Karlstad University and Ryan Beckett from Microsoft Research have agreed to act as the program committee chairs for that workshop. They're in the process of putting together the call for papers and the program committee, so look out for the call for papers probably early in 2025, and expect a paper submission deadline in April 2025. So if you have applied networking research papers, please do consider submitting to that workshop. In addition to the workshop, we also run the Applied Networking Research Prize in conjunction with the Internet Society and with sponsorship from Comcast and NBC Universal. The prize rewards some of the best recent results in applied networking. It rewards interesting new research that is potentially relevant to the Internet standards community. and it supports and rewards upcoming people that are likely to have an impact on internet standards and technologies. The call for nominations for the 2025 Applied Networking Research Prize is open. It's open for another couple of weeks until the 15th of November. So if you have or are aware of any excellent applied networking research that fits the goals of this prize, please do consider nominating via the URL on the slide, irtf.org/ANRP. We're very much looking forward to your nominations, and we rely on your nominations to get the excellent set of papers which we've had over many years, and the excellent set of people we've had over many years for these prizes. And on that subject, we will be making the last two ANRP awards of 2024 today. We're making two awards, one to Sosan El-Zahar, hopefully I pronounced that correctly, for her work on reducing the carbon footprint of internet routing, and one to Mingxi Wu for his work to understand the censorship of fully encrypted traffic. And again, the papers and the slides are online, and the talks are coming in a couple of minutes. And with that, I think that is all I have to say. The agenda for the rest of today, we have a very short presentation by Yves Schuler next to advertise a potential sustainability research group we're considering chartering. And following that, we have the two prize talks from Sosan first, talking about exploring the benefits of carbon-aware routing, and then from Mingxi Wu later on, looking at how the Great Firewall of China detects and blocks fully encrypted traffic. With that, I'd like to congratulate the prize winners and invite Yves up to the stage to talk about the sustainability group. No, that's for this laptop. Just tell me next slide.
Do I just get to sit here?
Microphone.
Do you want me to control that?
No, I'll do it.
Hello. Okay, I'm Yves Schuler, and this is a proposal with my colleague Ali Razaki, as well as Michael Wetzel. And this is meant to be an enticement for you to attend a Wednesday side meeting where we're going to discuss a proposed charter. Next slide, please. So why do we want to create a research group in this area? Why now? Things are fairly urgent. There's increasing urgency.
Microphone.
Closer.
Closer.
Wow, I thought I had a loud voice. All right. With increasing urgency, we are being asked to really adhere to the recommendations of the venerable organization at the UN, which is the Intergovernmental Panel on Climate Change, to observe this, to avoid the most catastrophic side effects of climate change by adhering to this threshold of 1.5 Celsius degree increase of the heating of the planet. And to do that, the recommendation has been to really adhere to this timeline, which is to reduce our emissions by 50% by 2030 and 100% by 2050. That's not very far off. And the emissions are greenhouse gas emissions, which include carbon. When we ask, what is the ICT or the information communication technology sector doing about this, under which I would say the networking community falls? Well, our emissions are increasing significantly. And furthermore, even though data centers get a lot of attention for the amount of impact that they have, networks apparently have as much or more of an impact on the environment. Some of that may be changing, but all of which has been exacerbated by the growth of AI. Next slide. In the community here, when we talk about green or sustainability, it's often looking very narrowly at the consumption of energy. And while that's a good first step, and it is a necessary step, it's not sufficient. We can't energy efficiency our way to zero emissions. And thus, we need to really also be focusing on the environmental impact by decarbonizing the kind of electricity that we use. And furthermore, there are additional metrics of success regarding other environmental concerns such as water usage, land usage, pollution, and waste. Next slide, please. The broader community, however, looks not only at environmental concerns, and their definition for sustainability is to meet the needs of the present without compromising the ability of future generations to meet their own needs, which I think is very wise. And so in addition to environmental pillars or factors, they also propose social and economic ones. There are about 17 of which that have been defined by the UN, which are referred to as the Sustainable Development Goals. And you can have a look at the slide to read the fine print there. Next slide. To give you a sense of what we mean when we talk about beyond the technical environmental concerns, you can think about the internetworking community at the moment is consuming as much electricity as some developed nations, such as the UK. So who or how to effectively and responsibly manage something like that? Countries are being asked to manage to a timeline and deliverables. Why aren't we? There are also issues like, whoops, back please. There are also issues around the rebound effect or Jevons paradox, where we make efficiency gains only for people to realize that, we've got greater efficiency, things cost less, and wow, let's use things more because they cost less. And that's a phenomenon that happens over and over again, which is happening now with the internet as well. So how to make efficiency gains stick, and then how can we opportunistically take advantage of the fact that there needs to be some reconsideration of the architecture of both the electrical grid and the internet as more of those infrastructures get deployed into the universe to meet electrification goals for transportation, for example, and heating and cooling. We're going to have to generate 2 to 4 times as much electricity. And so the idea is, can we use, well, one, we need to have more renewables, and 2, we need to think about the co-design and co-location of the internet and or the networks and other things like data centers and the electrical grid. And so this is going to be quite disruptive, but it's also a wonderful opportunity to rethink architecture. There's also other socio-technical and financial considerations, both to incent for-profit businesses, many of the companies we work for, to think about, how do you incent them to care about sustainability while also it being profitable? So that would help accelerate the uptake of renewable energy, but there are also regulations that are forthcoming, and how do we as a networking community avoid situations like regulations that have impacted the data center community and servers where they've been required or at least recommendations have come down and regulations have come down that are now voluntary but could in the future be mandated to observe things like power proportionality, to observe true idle, where the idle power of servers is much, much lower than the maximum power usage at full utilization. So we don't have those kinds of regulations, but other parts of the community do. And then finally, there's a whole collection of ethical questions that much of this raises. Next slide. So what we're putting forth in this for this research group is to consider long-term research contributions with a network perspective lens. And on the one hand, we want to investigate things that fall within the internet IETF community to investigate further, while at the same time balancing with kind of an educational purpose to understand these adjacencies in communities like those that pertain to social and financial or economic sustainability. And so come to our meeting and hear more about each of these topics. Next slide. Clearly, there are many others within the community with whom we'd like to collaborate, research groups, working groups, as well as the IAB and the Internet Society. And we'd like to solicit participation from industry, academia, and government researchers. And to echo something that was said earlier, we're deferring standardization to the IETF, but we want to produce RFCs and so forth. So come to our side meeting. We're going to be discussing our proposed charter, and it happens on Wednesday, November 6th, and it is happening at 2:30 in the afternoon in Wicklow Hall 2A. Thank you very much.
Okay.
Any questions?
Thank you, Eve.
Okay.
One quick question, Rodney.
Are we doing questions? Is that okay?
Yep, just quick.
Okay. The one comment where you said DC, when you first put that up there, I wasn't sure if it was data center, direct current, or District of Columbia.
Data center. Data center.
yeah.
Yeah, from the previous slide that was about socio-technical and financial issues.
So question, one buzzword I haven't heard you mention in about 3 times similar topics have been talked about so far today. Do you consider e-waste and also the cost of metals mining and things like that for the production of the equipment? Are those in scope or out of scope for what you're doing?
They are in scope. That's not to say that we know exactly how to solve some of those things, but they certainly fall in the environmental life cycle of the things that we produce. Particularly, anytime you create something physical, you have to think about its life cycle. The manufacturing of it, the recyclability of it, does it have a second life, reusability, and so forth. And yes, rare earth minerals are a perfect example of some of the considerations around sustainability.
For what it's worth, I'm in favor of the RG.
Thank you. See you Wednesday.
All right, thank you. And as Eve says, please go along to the side meeting on Wednesday. Okay, so I'm very pleased now to introduce the first of our 2 ANIP award-winning talks today from Sorsan, who will be talking about exploring the benefits of carbon-aware routing. Sorsan is a third-year PhD student in the Computing Infrastructure Group at the University of Oxford and a graduate research fellow at Netflix. She received her bachelor's in electrical engineering and a Master of Science in computer and communications engineering from the Lebanese American University. And her current research focuses on reducing the carbon footprint of computer networks. She focuses on carbon emissions rather than on energy consumption alone. And her research combines routing algorithms, power modeling, and net zero solutions. Yeah, thank you.
Thank you for the introduction.
Thank you. Congratulations on the award, and over to you.
Thank you. So hello, everyone. Can you hear me well? So I'm Sausan. I will present to you my work on exploring the benefits of carbon-aware routing. This is a joint work with Paul Gunning from British Telecom, BT, and my supervisor, Noah Zilberman from Oxford. So to reach net zero goals by 2050, we have many initiatives. So a lot of researchers focus on computing, which is mainly done in data centers, because a data center can consume 10 to 20 terawatt hour per year, whereas for networks, where we have the data transmission, a network can consume 3 to 6 terawatt hour per year, which may seem less significant. However, there are much more ISPs than data centers, and these small contributions of ISPs will sum up, and consequently, the carbon emissions of the network are not negligible. So starting with a simple network, a simple example, if we want to send a packet from router A to router E, in this case, we have 2 paths. So if we look at the problem from an energy efficiency perspective, we would choose the shortest path because this means less routers processing the same packet. And in this case, we would route through B. However, these routers are placed at different locations, which means that they are fed from different energy sources. So for example, in this small network, if the routers on top are fed from renewable energy and the router in the bottom has fossil fuel energy, it could be better now to route through the upper path because it could be a greener path. So this is the concept of carbon efficiency. So this also adds the geographical dimension of the energy mix to the routing. So one opportunity is this energy mix of the grid is actually predictable. So we take this metric, we incorporate it into the routing process and check how much can we save on carbon emissions. So this is the goal of this work. The scope of the work is only for the routing, so at the network layer, and we only consider operational carbon emissions. So operational carbon emissions are the emissions related to the energy consumption. We don't look at the, for example, embodied carbon to manufacture routers or the end-of-life carbon emissions. So only operational carbon emissions. So the first step is really to understand the building components of the carbon footprint of networks. So the carbon footprint depends on the amount of energy consumed, and then the source of the energy, and then the weighted carbon emissions associated with the source. So the last two terms can be summarized by the term carbon intensity, and I will explain each of these now. So first of all, for the energy consumption, we need a power model for the routers. So a router, even if it's not processing any traffic, would be consuming some power. This is the idle power, which you can see in yellow. And then once it starts processing some packets, you would see some increased power that is close to be linear with the utilization, and this is the blue part. Now, a note is this idle power can be further divided into a static power and the power to enable every port. So whenever we want to connect a link to the router, we need to enable one port, and this consumes some power. So the idle power is both static power and then the power for every port, and we have the dynamic power. So that is for the energy consumption. Now, the carbon footprint is the product of this energy consumption with the carbon intensity. So the carbon intensity has a unit of grams of CO2 per kilowatt hour. So it measures how many grams of CO2 are emitted to the environment to produce 1 kilowatt hour of energy. So for example, for oil, the carbon intensity is around 900 grams of CO2 per kilowatt hour, whereas for renewable energy, it could be close to 0. So from 900 to 0, that's a big difference per kilowatt hour. So in the graph, we have the average carbon intensity in the UK for different seasons. And on the x-axis, you can see a 24-hour timeline from midnight of one day to the other. So this carbon intensity varies a lot between seasons, but also during the day. And we can see significant change within a few hours, which means that we cannot just take an average value of this carbon intensity, but we need to take the time granularity of this metric into account. A last note on this slide is this carbon intensity is predictable, and it can be forecasted up to 24 hours or even 48 hours ahead of time, which means this is enough time for planning ahead. And this was one of the main motivations to do this work. So now, knowing that this carbon footprint depends on both energy and carbon, we go and define a set of energy-related metrics and carbon-related metrics. Now, why do we need metrics in the first place? So we need some indicators to express the power model of the routers and this carbon intensity that I talked about before. So the goal is really to evaluate how using these metrics can help us to reduce carbon and energy. And what we want to do is to know which metrics are more important to reduce carbon and energy for routing specifically. So the use case in this work is just routing. So the first energy-related metric is the typical power of the router. So this is the power at 50% utilization, and it can be extracted from datasheets. Now, one problem with this metric is if we consider interdomain routing, ISPs would not be happy to share the typical power of the routers because it can hint on the type of equipment that they are using. So we came up with another metric, which is the energy rating of a router. Just like air conditioners and TVs, energy rating could be a convenient metric that ISPs are willing to expose. So this energy rating is not standardized yet for routers. And so we just start with a simple definition in this work. It can be defined differently, but we start with this definition just to introduce the metric and test it in this work. The next energy-related metric is the incremental dynamic power per unit of traffic. So for this one, we only look at the blue part, the dynamic power, and we divide it by the maximum capacity of the router. So the unit here is watts per megabits per second. So that's it for the energy-related metrics. Now moving on to the carbon-related metrics. The first metric is obviously the carbon intensity. And the second metric that we considered is the carbon emissions per router. So this metric is considered because most of the monitoring tools that we have now can give you the average energy consumption of the router for the previous interval of time, like for the previous 30 minutes or 1 hour. And then if we multiply this energy consumption by the carbon intensity during that period of time, then you can get the carbon emissions of the router for the previous interval of time. And this is the metric that we considered. So that's it for the metrics, but we can also use some combinations of these metrics, specifically for the routing optimization. For example, we can combine the carbon intensity with the incremental dynamic power per unit of traffic, and the result of this would be the incremental carbon emissions per unit of traffic. And as we will see later on, this metric turned out to be a really efficient metric. And also to note that we are considering this in the intra-domain thing, so we don't have any privacy issues. So inter-domain routing is a different story. So we want to test these metrics. We want to evaluate them. We have two approaches in this work. The first one is a very naive one, just change the link cost based on these metrics and then apply the Dijkstra algorithm. So for example, in this small network, if we take the carbon intensity to be the link cost, then in this case, we have two paths that have the same cost, and with equal cost multipath, the traffic would be split between the two. And then if we add the energy rating, for example, we would have different routing tables and we would have a different routing. So that's it for the first approach. Now, this first approach would only make a difference for the dynamic part because everything is still on. Everything is still consuming power. So the next obvious step is to try to shut down unnecessary links. So we want to also reduce the idle power. So the second approach is a carbon-aware traffic engineering approach. It's not the first time that this, like shutting down links is suggested, but we test this one from the carbon efficiency perspective, and we combine carbon-aware routing with shutting down links. So this approach is a carbon-aware traffic engineering-based heuristic that we denote by Kate. And what it does is, after changing the link costs, it also picks the least utilized links with the highest carbon emissions, shut them down. It checks if the network is still connected while keeping some redundancy, because redundancy is important. And then it checks if the improvement introduced is still positive. So ISPs these days can predict this traffic. They know when the traffic levels are low. And because also the carbon intensity is also predictable, then this is enough time for planning. So this planning ahead is doable, and it presents a great opportunity for carbon savings. So this work is a simulation-based work that we did using NS3 simulator, and we tested it on real network topologies like British Telecom, BT in the UK, which is a main ISP with more than 1,000 nodes. And we also tested it on Giant, which is an educational network based in Europe. So before proceeding to the results, I want to highlight on the traffic patterns that we considered, because they turned out to be a game changer. So we have two traffic patterns, the daytime traffic and the evening traffic. So during the day, the traffic is dominated by business customers. The pattern is mostly symmetric, like from any node to any node, and the overall throughput is almost constant during the day. Whereas in the evening at 8 p.m., everyone is watching video. So the residential customer traffic dominates. It's mostly downstreaming of content from caches. So if we look at this diagram, which is the hierarchy of the BT topology, we have some core nodes, then some metro nodes, and some tier 1 nodes. And caches are mostly collocated with metro nodes. So the flows in this case are downstreaming from these caches to all other nodes, which is like these flows have really short paths. It could be only 1 or 2 hops away. And we will see the impact of this later with the results. So now moving on to some results. So in this figure, we see the carbon savings and the energy savings with respect to OSPF. On the x-axis, we see the metrics that we considered, including the combination of metrics as well, and we have also Kate. So starting with the energy-related metrics, we see that the incremental dynamic power per unit of traffic has the highest carbon savings. But this is only energy efficiency because carbon is not considered yet. And then for the metrics that include carbon, we see that the carbon savings are a bit higher, but this is at the expense of like 5% path stretching. Path stretching is the increase in the average number of hops that a packet needs to travel. And among these metrics, we see that the combination of carbon intensity and incremental dynamic power have the highest savings. But also a note here is we can notice that in some cases, carbon savings are positive, but energy savings are actually negative. So why is that? It's because this is, again, the carbon efficiency versus energy efficiency. So it's true that we are consuming some more energy in some cases, but this is green energy that is consumed. And the overall carbon emissions are actually less, as we can see from the positive carbon savings. And finally, Kate, which is shutting down links plus carbon-aware routing, we have the highest savings, both carbon and energy savings, and carbon savings are up to 15%. So that's it for the daytime traffic. But now for the evening traffic, the improvement just vanished. So the carbon savings are really negligible, and this is because these flows are mostly have short paths. So if the route is like you only have 1 or 2 routes that are so short, and so carbon-aware routing won't change anything. Plus, at peak times, we cannot also shut down links. So for this case, we need to consider other approaches. So back to daytime traffic, if we want to see how the flow intensity changes per region, this is, for example, for the UK. For the first graph, we can see the carbon intensity for the UK in 14 different regions. So there is one website called Carbon Intensity API that divides the UK into 14 regions and reports the carbon intensity per region every 30 minutes. And then the 2 other maps are the flow intensity in gigabits per second per region. The first one is with OSPF, and the second one is with carbon-aware routing. So starting with Northwest England and East England, the flow intensity with OSPF was like close to 350 gigabits per second, but with carbon-aware routing, the flow intensity increased to 500 or 600 gigabits per second. So why is that? Northwest England, we see that it's really green, but East England is not that green, right? But it is actually greener than its surrounding, and that's why it's hosting more flows. Now, if we look at East Midlands and South England, these are clearly less green, and the flow intensity decreased from around 350 to 250 gigabits per second with carbon-aware routing. Now, finally, if we look at London, well, London stayed the same because London actually has a very high density of it's the high density of nodes. So it's like a bottleneck in the topology, and we cannot route away from London. And this is the concept of like bottlenecks in a topology. So if we want to see similar things for the giant topology, so here it's the same thing. We also have the flow intensity for different countries, for OSPF and for Kate, which is carbon-aware traffic engineering. The top 3 countries that are hosting the most flows are France, Italy, and Germany. Now, if we look more closely on the values, for France, the flow intensity increased from 191 to 282. For Italy, it increased from 188 to 217 because France and Italy are like greener than other countries. But for Germany, the flow intensity decreased from 270 to 203, which means that carbon-aware routing tried to avoid Germany, but it could not avoid it much. And this is, again, the concept of bottlenecks. So Germany is like a bottleneck in the GEON topology. Now, the last aspect of the simulation was to look at the impact of changing the ratio between static and dynamic power. So back to the diagram of the power model, we have the static power and the dynamic power. So the ratio between the static and dynamic, this is the ratio that I'm talking about. And different routers would have different values of this ratio. For example, chassis-based routers have very high static power, and which means that the ratio in this case would be very, very high. So in the graph, we have the overall carbon savings with both carbon-aware routing and CATE, which is carbon-aware routing plus shutting down links. And we see as we increase this ratio, which means the static power is higher, these savings just diminish. So we go from 14 or 15% up to like 1 or 2%, which means that obviously it's better always to invest in replacing equipment with lower static power routers. So the main takeaways of this study are, first of all, in terms of metrics, the combination of carbon intensity and incremental dynamic power per unit of traffic are the best combination of metrics. The second takeaway is about the energy labels. So energy labels are good for purchasing. This is a nice metric to have, but it did not present a lot of benefits for routing in this case, maybe because of the simple definition that we have, but we can actually refine it more. So this is like future work. The next takeaways are about the limitations. First, the high idle power limits carbon savings, and also bottlenecks in the topology also limit carbon savings. And finally, carbon optimization is application specific, because as we've seen for the downstreaming of traffic, the carbon optimization was limited, and we need to look at different approaches in this case. So that's it for this work. The code is available on GitHub if anyone is interested in NS3 codes. And thank you.
Thank you. All right, thank you. Fantastic talk. I see we have a couple of people in the queue. Chris Box.
Hi, Chris Box. I work for BT, but I wasn't involved in this work. But first of all, thank you for the presentation. It's really interesting. I believe, I mean, so I think I'm correct that this wasn't built using data from the real BT network, but a simulated version using public domain data.
Yes.
Now, so this is all talking about how can we efficiently, what is the most efficient way of routing traffic across a network? But I'd also like to think about the question of also considering a decision, should we inject traffic into a particular network or not? Or should we send data in at a particular time? Which network should we choose? So for example, on a smartphone, I have two networks available. I can go over Wi-Fi, I can go over the mobile network. Those would have different carbon costs. Now in the IETF, we have a new working group called SCONE, and that's chartered to provide information from the network to the client application. And that it happens to be that the charter is just giving throughput advice to the application. But in theory, I could think about something similar where the network informs the client application something about its carbon cost. And therefore the client can decide to choose a less carbon generating route. Do you think that seems reasonable?
Yeah, sure. So one of the next works that we are working on is to like the carbon tracing concept, which is like you want to know this flow, how much it contributed to carbon, and to provide some alternatives to the user, similar to what you say, like different, is it Wi-Fi or mobile, or is it, for example, downloading a video now or after 2 hours? So these are like future work. But in this work, we only considered the core network. Yeah.
Okay. Thank you.
Thank you.
All right, thank you. Brian.
Hi, Brian Trammell, co-chair of the aforementioned Scone Working Group. Come by on Thursday morning. So I had, thanks a lot for the presentation. This was really cool. I had one quick clarifying question about sort of looking at the dynamic, so over in the bottom right corner here, so the static dynamic power graph. Did you in the model consider shutting down all of the links to a router so you could shut the router down?
No, because every node that we considered is already having some local traffic, so we cannot shut down the router.
Okay, right, because
Yep.
okay, cool, thank you.
All right, thank you. Dave Planker.
Hi, Sasan. Thanks for joining us. Really nice to have you here and show some of this work to the operators and the standards people. One of the parts of your talk that I was struck by, not having thought about it before, was that you said the inter-domain routing problem is that you have a privacy issue where the provider wouldn't want to disclose their infrastructure. But then you used an example in this last part which talked about accessing caches which were presumably consumer content outside. Was that limitation disregarded there? Wouldn't the content that people are drawing by streaming be from outside their domain? So that's one thing that I didn't quite grasp. And then maybe to broaden that was, what could we do, even apart from your work, to incentivize people to want to do this? In the US, for instance, you can pay more for your electricity to get renewable energy. Did you guys think of that, or do you have any thoughts since about, would somebody be willing to have their video quality compromised to make these carbon things, or would they be willing to pay more to get better quality? What do you think?
Two questions. The first one is about the caches. So these caches are inside the network, and we're talking about the flows. So these flows are part of the same network.
For instance, in what service?
Mhm.
Why would the caches be inside the network? I know of one CDN that does that, Akamai, and the other ones are outside.
Yeah, but the flow, like, so this is only for the intra-domain. So whenever the flow comes, once it's inside the intra-domain network, this is the property of the ISP to change its route.
So,
right?
so you're still, but you don't. So you're saying it's still limiting the carbon consumption aspect inside the network where the consumer of the traffic is.
Yeah.
And not that wasn't reporting any optimizations, or wasn't expecting the outside providers to disclose their carbon.
No.
Okay,
no,
thanks.
And the second question
The other part was just more open-ended about how could we, you always think of like, well, why would someone implement
the
this?
renewable energy credits.
What
you're
would be
saying.
the incentive, and like, could you see users willing to change their experience to be more carbon respecting or use less carbon, or could you imagine them paying more for their internet service to get the one that uses less carbon, which is what some people do in the US with power for their house right now?
Yeah, so one thing is like greener is not cheaper, but like using the renewable energy credits, ISPs are actually paying more, and it does not guarantee that they are actually using this renewable energy. They could be just paying more and just to claim that they are green. So this approach actually have like actual carbon savings. It's not like, but obviously it does not offset all the carbon. So they would still need to do something to claim that they are 100% green. But this is like actual carbon savings versus not just claiming to be.
All right, Doug Trusson.
Hi, Doug Trusson. Love the presentation. Thank you very much. I was piggybacking on the first question, which kind of extended the routing decision you're doing on the link decisions to determining where to actually go, which means the traffic steering part. Have you considered to make decisions about incorporating the endpoint decisions, so where which particular location you're picking over another one to extend the word from carbon aware routing to carbon aware traffic steering? Have you thought about that?
So what do you mean by the endpoints? Like who would be doing this decision?
So which of the endpoints? So we have a work in the IETF on what's called computer-aware traffic steering, where the actual destination of a service is being picked based on compute capabilities, but you could extend this quite easily to energy capabilities. Do I want to send my data, which could be served from 5 different locations in the network, to a location that is actually, less carbon intensive than another location.
So in this work, we consider the flows like from one point to the other, and it's just the path that we are changing. Yep.
Yeah. So it's entirely focused on routing, not on.
Yes. Yes.
Okay. Thanks.
Welcome.
All right, thank you. I also had one question. I mean, you based your results on data from the UK and from the Giant network, and that makes sense because of where you're based and because of the data that you have that's readily available there. Do you have any data for other parts of the world, and do you have any feel for to what extent the sort of networks you're measuring are representative?
So like BT has some good hierarchy of core metro tier 1, which is similar to other ISPs. But I want to highlight on the differences between countries in terms of carbon intensity. So for example, in Italy, carbon intensity between regions could not be that high. So the UK actually has a high variance of the carbon intensity. So if a country does not have a big carbon intensity variation, the problem would go simply from carbon optimization to energy optimization.
Right. Okay, great.
Thank you.
All right, thank you very much. Thank you again. All right. Okay. Okay, so the second speaker today is Mingxi Wu. Unfortunately, Mingxi had visa issues, and so is remote, and I believe he is also having camera issues, but hopefully the sound is working at least. His presentation is on how the Great Firewall of China detects and blocks fully encrypted traffic. Mingxi is strongly passionate about research and activism in the area of censorship measurement and circumvention. And over the past 5 years has led, the work he's led has helped millions of users in China and Iran to bypass various engineering censorship challenges. His work has received several awards, the IMC Best Paper Award, and so on. And he's a recipient of the Foki Rising Star recognition and has received considerable media coverage for his work. He's also the founder and a core contributor to the GFW Report website, an English and Chinese website focused on studying and understanding censorship. And his talk today is looking at how the Great Firewall of China detects and blocks fully encrypted traffic. Mingxi, over to you.
Oh, thank you, Colin, for the introduction. Hi, everyone. My name is Mingxi Wu. I'm from the GFW Report, and today I'll be presenting our work on how the Great Firewall of China detects and blocks fully encrypted traffic. And this has been a joint work with CU Boulder, UMass Amherst, University of Maryland, and also the V2RE project. Before I dig into the censorship incidents of what happened in China, I'd like to introduce a little bit more about what the internet looks like in China. If you're inside of China, you cannot go to Instagram, Facebook, Twitter. You cannot go to Wikipedia. You will not be able to use your Gmail, or you cannot even use your YouTube. You cannot watch YouTube videos, unless you use some type of censorship circumvention tools to help you bypass the censorship. And as you can see, as a normal Chinese netizens, people usually have multiple censorship circumvention tools backed up on their phones because there has been an ongoing cat and mouse games with the Chinese government and Chinese netizens. So when one of the circumvention tools doesn't work, you don't panic. All you have to do is to try another one. And there usually gonna be one that will be working. So there are so many different variety of censorship circumvention tools developed by different parties. For example, as you can see, the Sandbox, V2RE, these are the well-regarded open source circumvention tools developed by circumvention tools community. The paper airplane over here you can see is one of the most popular circumvention tool called the Shadow Socks. Tor project has their own anti-censorship team developing circumvention tools. Outline developed by Google Jigsaw. Typhoon Lantern are the two of the biggest players on the censorship field, funded by the US government. So when people ask me about what is fully encrypted traffic, I have been telling them that fully encrypted traffic is the cornerstones of censorship circumvention tools. That's because regardless what the brand it is, which one is because what the protocol details it is, they all fall into one simple philosophy, which is that when you are inside of China, you'll be installing a Shutterstock client, for example, on your phones. This client will help you to encrypt every single byte of your network traffic, sending it through the Great Wall of China. And then the proxy server, the Shutterstock proxy server will request the websites on your behalf, sending the encryption traffic back. So between the Shutterstock client and the server, what the Great Firewall of China can be seeing is completely just a random, fully encrypted traffic. So they won't be able to tell what you are going to. The philosophy of this has been working for more than 15 years since the first invention of the fully encrypted proxies. Until one day in November the 6th, 2021, when the censor has been able to start a dynamically block fully encrypted traffic in real time. And these blocking incidents actually is 12 days before the 6th preliminary session of the 19th CCP Central Committee conferences, which was when the time that Xi wants to change the constitution and seek his unusual third term. So what happened on that day is that the Chinese, on November the 6th, 2021, the Chinese netizens wake up in the morning, like usual, they want to just turn on their VPN, to go to YouTube, go to Twitter. What they realize is that also, for example, one of their tools doesn't work. At that time, they do not panic. All they need to do is to, like usual, they change it to another VPN to try it. But still, it doesn't work. They do not panic. They try the other one. But people started panicking when they enumerated all the solutions they have on their phones, and none of them works. And that's when people started panicking. We heard about the news and started for measurement within 24 hours. So what we found is that we set up our own client inside of China and our own server outside of China. What we found is that when we try to connect it to our Shutterstock servers outside of China, within 0.01 seconds, the Great Firewall of China has already been able to determine whether you are using the fully encrypted traffic-based proxies, and they will be blocking your traffic. So say if they see you are using the VPN, within the next 3 minutes, they will blocking all traffic coming from your client to your server port for 3 minutes. So what we did is that we sent out a Twitter just telling the people saying, hey, we confirm the Great Firewall of China has been able to dynamically block any seemingly random traffic in real time. And such capability potentially affects a large set of censorship circumvention tools, including but not limited to Shutterstock and VMS. A detailed report is coming soon. Just one single tweet actually gave us millions of views, hundreds of reposts, thousands of likes. And the reactions from the people are, thank you, someone is kicking in to help. The positive reaction from all our Twitter followers and all the Chinese netizens make us really want to do this work well. We want to quickly figure out what was going on. So what we do is using the network measurement techniques to probe around the Great Firewall of China. Network measuring is a fancy word. What we really do is that we set up our own server inside of China and our own server outside of China. We send the different traffic patterns from China to the US or China to the outside world and see whether if I send this pattern, will that be blocked by China, Great Wall of China? If I send that pattern, will that be blocked by China? And using these measurement techniques, we were able to successfully, after extensive analysis, we were able to fully reverse engineer the Great Wall of China's traffic analysis algorithm. Don't get intimidated by all the details over here. I will go through them one by one. But I want to comment on the highest, this censorship circumvention algorithm at the highest level. I must give some credits to the Chinese censor. They are very, very smart in terms of they are having an engineering mindset. What they are saying is that, yes, these type of protocols, fully encrypted protocols, has been successful for 15 years, simply because one thing. If you cannot define it, you cannot block it. And Chinese censor actually think the other way with a very smart engineering mindset. What they are saying is that, yes, we agree. Throughout 15 years, nobody can define what is fully encrypted traffic. But what if the other way? I'm sure, or I can define what is guaranteed to be not fully encrypted traffic. And I'm going to let the traffic go. I'm going to exempt it. But if I give you so many different tests, if one of them matches, I'm going to let your traffic go. If I give you 1, 2, 3, 4, 5 different opportunities to exempt your traffic, but none of them of your traffic fall into this category, well, too bad. I'm going to block it. So that's the general philosophy used for the sensor to do the traffic analysis, to detect fully encrypted traffic. They're using something like, let's say, the entropy test. For example, they're doing the monobit counting. So imagine the fully encrypted traffic, backup cryptography, is that when something is fully encrypted, it's indistinguishable from completely random traffic. And when your traffic is completely random, it usually consists about 50% 0 and 50% of 1. So the sensor will be using one of the tests saying that, hey, so if I will be counting how many zeros are there, if there are 100% of zeros in your connection, it's very unlikely that's completely random. But if it's, let's say, fall into the range of around 50% 0, 50% 1, well, your traffic is more likely to be completely random or fully encrypted traffic. Then I'm going to block it, or I'm not going to exempt it. The sensor will also be having the engineering mindset trying to make their algorithm very, very efficient. They also say, okay, I'm looking at the first TCP payloads of the traffic of the client you're sending. If it starts from the GET or POST, those HTTP words, it's probably HTTP traffic. It's probably not completely random. And I'm going to just exempt your traffic. They're also saying, okay, if the first 3 bytes of your traffic is a 160301, well, that sounds like tells the client hello messages. I'm going to just exempt it. So basically they are doing fingerprint on the protocol-based exemption. So what we found is that also sensor and also have another engineer mindset is that they are now saying for every connection that it seems to be fully encrypted traffic, I'm going to block it. In fact, only about 1/4 of the connections are actually blocked by the Great Wall of China. Why is that? Well, I can think of 2 benefits. One is that they are actually sampling the traffic, so they are not overwhelming their network traffic. Since they are processing traffic at hundreds of gigabytes per second, so they really want something very efficient. The second possibility is because, yes, there may be some false positive in their detection algorithm, but by reducing the likelihood I'm going to censor it to 1/4, I'm actually reducing the absolute number of false positive to 1/4. while still making their blocking very effective. Because remember, so once you got detected, within 3 minutes, you cannot be sending anything. So from the user experience, it will be very, very bad. What we also found is that they are not saying, oh, let me apply this censorship algorithm to all the destinations outside of China. They're only focusing on those, let's say, for example, DigiOcean or those VTS hosting websites, because that's where the Chinese citizens are able to buy those servers, set up their own Shutterstock server, VMS servers, and use them. So, and that's where the censor was only censoring only 2% of the IP addresses in total. But it still remain very, very effective because the Chinese netizens relies on these type of services. At this point, you may be having two questions. So one is that, so say, hey, you already reverse engineered their traffic analysis algorithm. One thing is that you may be asking, seems to be very, very crude heuristics, and how efficient or how good or how accurate this censorship algorithm is. The second question you may be wondering is that, well, if you are just poking here and there, how are you making sure that what you are doing or your reverse engineered algorithm is actually relatively more comprehensive? You said there are 5 exception rules, but how are you going to make sure there's no fixed one that you didn't discover? And that's where the power of evaluating the sensors detection algorithm on the real world traffic is. We actually re-implement the sensors detection algorithm and actually put it on the university tab without implementing the blocking functionality. What we found is that only 0.6% of the traffic would not be exempted by this traffic by this censorship algorithm. And since it is because we are deploying this code in US university, it's less likely people are motivated to really use those circumvention tools. So the 6% that are blocked are possibly be false positive rates. We answer the second question. So how comprehensive are our reverse engineering efforts? What we do is that we say, what we found is that we see, okay, so these are the traffic or pattern that would be blocked by our implemented traffic analysis algorithm. We replay them through from China to the US through the Gulf of China. And what we found is that what we predict that should be blocked was actually indeed blocked by the Gulf of China, which shows the comprehensiveness of this traffic analysis algorithm. So once we realize, so this is the power of the censorship measurement. Once we realize how sensor has been detecting this sensor, once we realize how sensor has been detecting those sensor fully encrypted traffic, we are very easily come up with very different ways that we can use to bypass the censorship. For example, you can say you are still using fully encrypted protocol, but you are going to prepending the HTTP GET, the 4 bytes over there with minimum overheads. Or you can be saying that, okay, I'm going to be padding a bunch of zeros or a bunch of ones to our fully encrypted traffic to make the ratio of 1 and 0 not 50 and 50 anymore. And then we do a bit level of shuffling using a shared secret between the client and server. And we are very, very proud that we are in a very united community. Once we figure out the circumvention solutions, 1 month later, 1 month before, 1 month after circumvention tools has been blocked, we told all the circumvention tool developers saying, hey, if you can tweak your client this way or that way, you will be able to bypass the censorship again. And within 24 hours, all circumvention tool developers we contacted were able to make this change, merge the request, recompile the binary, and distribute it overnight to the Chinese netizens. and we are proudly helping millions of users to be able to bypass the censorship again. Another very interesting thing that I want to draw more attention to is that actually we find this blocking incidents inside of China is strongly correlated with the political events. For example, we remember so that this blocking starts 12 days between the 6 plenaries of the CCP Central Committee, and she changed the constitution. And anecdotally, 2 days after she became the chairman of the CCP, which having his unusual third term, the dynamic blocking actually ceased. So this is we see strong correlation between the time when it begins and when it ends. And that's all. So if you have any questions, we're very happy to just answer any questions. Thank you, everyone.
Okay, thank you. Are there any questions for Ming-Chi? So Rod van Meter, then Tommy Polly.
Rod Van Meter, Carey University. So this is a very good talk and incredibly important work. Thank you for doing it. A very general question. What internet services outside of China does the government actually look on favorably? That is, what is it that prevents them from not just putting in a firewall that cuts off some traffic, but outright just cutting the fiber altogether? What value do they see in the internet outside of China, and is there a way we can leverage that to push as much traffic through as possible?
Yeah, that's a super good question. I think what you're asking is actually one of the fundamental questions for the censorship convention. It invites the concept of the collateral freedom or collateral damage, meaning that so the censor, if they're not willing to censor some type of services, can we be co-hosting this convention tool? Can we be co-hosting these services that help to unblock the traffic? One example of this is GitHub. So China has been worsened the experience of the GitHub, sometimes block it, sometimes unblock it, but still we can co-host, let's say, the binaries of the circumvention tools on GitHub. Another big player here I can see is actually the Cloudflare, and the IETF, IRTF has been doing an excellent job, let's say, coordinating, have the RFC of the encrypted client hello, where because it's a CDN and the IP addresses, if it got blocked, a lot of websites would be blocked at the same time. So yes, so GitHub, Cloudflare are definitely, and the other CDNs are the biggest players right over here that I can think of that China doesn't dare to block it or need to think twice before blocking it.
Thanks. That doesn't sound like a very large percentage of the total value of the internet. That's interesting.
Yeah.
Thanks.
Mm-hmm.
All right, thank you. I'm Tommy Polly from Apple. So again, echoing, thank you very much for this talk and sharing it. It's very important work. I agree with Rodney's overall point that was one of the things I was also thinking hearing this. Going back to specifically when you're talking about the patterns they're looking for, it was clear that there's something about the encrypted traffic that throws the flag, but that for TLS traffic, or specifically an HTTPS traffic pattern, that is going to be a flow that is generally encrypted, but is going to be allowed to certain important services, or maybe even just more or less by default, unless it is a known bad service that they want to be blocking. So it seems like you're using an approach of prepending that onto your otherwise encrypted traffic. So I guess the first question is, to what degree are you looking at simply using HTTPS as the tunneling mechanism? That's something that we are working on a lot here, and I've been working on a lot with others. And do you foresee that there would be particular problems where they would still detect anomalies in the length of a flow? Because if most HTTPS traffic that they would be allowing would have certain patterns, do you think it's already looking at something that may look like a longer flow that just starts out looking like normal HTTPS and they would still block it?
Yeah, no, that's a very, very good question. So back to the first question. So remember, so in the talk, what we do is that instead of we are really using a TLS connection, what we do is that we prepend the first 3 bytes of the 160301, pretending to be calling hello messages to bypass this censorship. This actually is something that we in the sensor circumvention field called parroting, that you are not really a TLS connection, but you pretend to be that. And this approach can be fundamentally flawed, backed up by the parity stat paper. But we see there is actually a little bit more dynamic than that. So during the time, it was the first circumvention strategy we discovered. And these people already have their client installed and unwilling to, or not technical enough to SSH into their server to update the server. But by just shipping a client set, there's changes to them, pretending only 3 bytes, using still existing protocol, we actually gained a lot of times for the Chinese netizens to bypass censorship in a efficient and quick way. But I totally agree with you. Ever since then, the shadow stocks or fully encrypted traffic has become just one branch of the cornerstones. And TLS circumvention tools like Trojan or other type of circumvention tools has been doing the TLS-based tunneling, and that's the right approach. So yeah, that's a very, very good question. Back to the second question, if I understood correctly, are you saying that maybe the sensor can say the long time connection between the client and the server, such large amount of traffic exchange between the client and server may already be a distinguished feature? Is that your question?
Correct. Essentially, like let's say to the point of, oh, you have you're hosting something on a server that would otherwise be allowed, and that server also is allowing you to tunnel through it. To what degree would it already be detecting an anomaly of, oh, it looks like you're connecting to this website, but you're exchanging 4 times the amount of data, or is that something that we should be anticipating in circumvention techniques?
I see. No, very good question. So let me just explain a little bit what my understanding. So you are saying that, for example, you're actually running a TLS server and you are hosting your own blog, but actually, in fact, you are also using the website as a TLS tunneling. But then people will go to your blog, be like, hey, you cannot be transferring, let's say, 100 gigabytes per night on your blog. That's way too much, right? That will be the one. So I see this definitely will be a way to actually identify circumvention tools. We have not have empirical evidence as China or the sensor has been using it as a way to detect it. Why is that? It is because there are so many different, really easy to implement, more accurate way to actually detect it. For example, the TLS fingerprints can be very, very unique. When you go to a website with a very, very unique TLS fingerprints in terms of the Sapphire suit, is very, very selective, they can easily block it. And that's what happened to Tor before. And that's what happened in large scale before in 2021, same year for the circumvention tools. Yeah. So that's a really good question.
Cool. Thank you. And I just encourage us to, in the cat and mouse game, be thinking several steps ahead.
Absolutely.
Hi, my name is Lars Eggert. I work for Mozilla. So this is a great talk. Thank you very much for submitting it, and congratulations on getting the prize. So I wanted to go back a little bit to what Rod talked about earlier. So if sort of one of the cornerstones to making the circumvention systems work is that some services are too valuable to block, like you mentioned GitHub and you mentioned the Cloudflare infrastructure. It's great that it exists, but it's an uncomfortably small number, and I'm kind of worrying about you know, either pressure being put on those entities from China to accommodate the blocking, and for some of them that seems unlikely. For both of these, it probably seems unlikely. But I wonder how we can increase the number of services that are sort of considered valuable. I'm also wondering if there's other things that other services can do to maybe become part of that if they were so inclined. I wonder if you had some thoughts on that.
Yeah, no, that's a good question. So first, we already very grateful that Cloudflare, Mozilla, and the Chromium are very sympathy to the privacy and the censorship work to doing. And my understanding, I thought is like, for example, is already a pretty good play a very important role for the CDNs on the circumvention censorship circumvention for the Chinese netizens these days. So maybe let's say 20% of internet is consist of let's say CDN nowadays. So, but indeed, so the more the better. Actually, the more variety, the better. So right now we see the obstacle in terms of the hosting IP addresses, right? So China was only spending efforts on 2% of traffic going to DigitalOcean, going to Azure, versus going to Akamai. So going to this type of VPS hosting websites. So if we have more diverse hosting endpoints, that will be definitely one thing that will make this give it the sensor more headache to keeping track of. Yeah.
I mean, more diverse, or like actually the opposite, like if everything is on one or a few number of IP addresses, right? The blast radius around those IP addresses will be so large that that might also be difficult to block then based on.
Right, exactly. I totally agree.
Okay. Thank you very much.
Yeah, no, thank you.
All right, thank you. There was also one question in the chat asking about the impact of encrypted client hello.
Yeah, so we are very excited. I think so the anti-censorship community talked a lot with a lot of people. Everybody are super excited about the encrypted client hello, right? We really know that's a second chance for the ES9. The ES9, we learned the mistake. We see the pressure. We see how it didn't work. And this time, we really appreciate that. So Cloudflare, Mozilla, Chromium, IETF all together, right, pushing it forward. And actually, if I understood correctly, even GFW report website has been long censored by Great Wall of China. Wood has already been unblocked now because we are hosting on Cloudflare, and if you just use Firefox, you can, with the DOH and the encrypted client hello messages, you will be able to access it. So I see it as a very promising future of it. We are very excited about it. Only one thing is that we really shouldn't fall back. So we really shouldn't just fall back in terms of, say, China, if they put pressure, say, I'm going to block all ECH connections or all connections from Firefox or Chromium for compatibility issue or usability issue. We shouldn't just give up saying that, oh, wow, so if China decide to censor that, we need to fall back to not using ECH. So, yeah.
All right, great. Thank you. Thank you again to both of us. Thank you again to both of our speakers. Those two absolutely fantastic talks. So congratulations to both.
Yeah, thank you, everyone.
So that concludes the meeting today. If you know any good, any equally good applied networking research that you think would be worthy of the 2025 prizes, please do consider nominating. Thank you, everybody.